Hi, I'm Jafreen Kazi, and my topic for video presentation is function, domain, range, and the properties of a function. Let's dive into each topic. So, how function come into the existence in the real world? In the 17th century, the French scientist Rene only discovered the mathematical relationship. Later on, the term function was introduced by the Gottfried in between 1646 to 1716, always 50 years after the publication of the geometry. Next, the idea of a function was further formalized by the Leon Hurd in 1750, who introduced the notation for a function y is equal to fx. So, what are the functions? Functions were originally the idealization of how a varying quantity depends on another quantity. A function is a relationship between the two sets of a data, one input and other output. A relation is said to be a function if and only if each of the input data is related to exactly one output data. In function, there are special name for what can go into and what come out of a function. What can go into a function is called a domain, and what may possibly come out of a function is called codomain. But what actually comes out of a function is called a range. In its simplest form, the domain is all the values that go into the function. And before we look into some examples, let's talk about little bit about range. And the range is all about the values that come out. Range is a little trickier to find than domain. Most of the time, we are going to have a look at the graph of a function to determine its range. So here are the some example. The example you have shown here, that A B C D E is linked with the range 1 2 3 4 5, but D is not included into that domain since function is not defined for the D. And 1 2 3 4 5 4 is the range, but the 2 is not linked with the any of the function, any of the domains. So this letter is in the domain, not mapped with the 2. The other example is more emphasis on the what is the domain and the range. What In fact, the domain is the essential part of a function, and change the domain and we have a different function. Even though both function take the input and the square it, they have a different set of input, so give a different set of output. In this case, the range of g of x also includes 0. Also, they have a different properties. For example, f of x always give a unique answer, but g of x can give the same answer with two different inputs, such as g minus 2 is equal to 4 and also g2 is equal to 4. So the domain is an essential part of the function. Next is the properties of the function. The properties of a function includes the injective, surjective, and the bijectives. Basically, it tells how the function behaves. A function is a way of matching the number of set A to set B. The below are the examples which exactly giving the meaning of what the injective, surjective, and the bijective behaves. The first twos are the general function points from each number of a to member of b. It never has one a pointing to more than one b. So many to one is not okay in a function. So something like f of x is equal to 7 to 9 is not allowed. But more than one a, one point to b, same. Many to one is okay. Injective means we won't have two or more. A is pointing to same b. So many to one is not okay, which is okay for the general function. As it is also a function, one to many is not okay, but we have a b without a matching a. Injective is called one to one. The fourth one is the surjective. Surjective means every b has at least one matching a, not more than, maybe more than one. There won't be b left out. The last but the not least, bijective means both the injective and the surjective together. Think of it as a perfect pairing between the set. Everyone has a partner and no one is left out. So there is a perfect one to one correspondence between the members of the set. Now we look some of the applications of the function. The first one is the ATM. When the ATM card is inserted into the machine, the program inside performing a function to map the number of sorted in the card to your current or saving account. This is basically a one-to-one mapping, that is function. It is probably the most widely and popular use of function. The second was the money time comparison. Money as a function of a time, you never have more than one amount of money at a time because you can always add everything to give one total amount. By understanding how your money changes over the time, you can plan to spend your money sensibly. Businessmen find it very useful to plot the graph of their money over the time so that they can see when they are spending too much. Last but not least, the thermometer. The temperature as a function of various factors. Temperature is a very complicated function because it has so many inputs, including the time of the day, the season, the amount of the clouds in the sky, the strength of the wind, where you are, and many more. But the important thing is that there is only one temperature output when you measure it in a specific place. This is what the thermometer deals with. It is a good example for many or to one function. Thank you so much for watching.